Hello everyone and welcome to TalentSprint. Our discussion in this session is going to be on a very fundamental topic from mathematics, and this topic is algebra. But before we go ahead and discuss anything about algebra, let me ask you a very simple question. What is the formula for simple interest? How do we calculate or how do we measure simple interest? I'm sure all of you know the answer for this question. Right? Simple interest is equal to P into T into R by 100, or simply PTR by 100, where P is the principal amount, T is the time period, and R is the rate of interest. So simple interest can be calculated as PTR by 100. Now what does this mean? The amount that has been given as a loan is P, right? P denotes the amount that has been given as a loan. What is T? T is the time period for which the amount has been given as a loan, and R is the rate of interest at which the amount P has been given as a loan for a time period of T years. Now if you really look at it, does it make any sense? What do you mean by the amount P? Is P really an amount? Can I say that I have given you P rupees, or for a time period of T years? Or for that matter, the rate of interest is R% per annum? Well, as I've said, this doesn't really make a sense. It has to be some numerical value, right? P should be some numerical value. R has to be some numerical value. For example, 5% per annum, or 10% per annum, or 12% per annum. T is the number of years, but T years? No. It should be 1 year, or 2 years, or maybe 5 years, and so on. And same goes the case with T, principal amount, 10,000 rupees or 20,000 rupees or 2 lakh rupees. But why do we say P, T and R? Well, this is what is algebra. In mathematics, very often the value, the numerical value of a given parameter is unknown. Right here we do not know what the principal is, or maybe let's say we do not know what the time period or the rate of interest is. So in such cases, the unknown value is represented using a symbol, generally a letter of the English alphabet, right? We usually use X or Y, but we can use any letter, right? So when the value of a given parameter is unknown, we use a symbol or a letter to represent that unknown number. And such letters or such symbols are known as variables, right? It is an unknown, or generally called as a variable. And algebra is a branch of mathematics which deals with such variables, right? In algebra, we simply use symbols or letters to represent unknown numbers in formulae or in equations. So in this topic of algebra, we are going to deal with such variables and its usage, right? Well, coming to the application of algebra, as I've given an example, it is used in almost every topic of quantitative aptitude, right? Or let's say arithmetic aptitude. Well, you might be wondering, how is it used everywhere? Well, without our knowledge, we actually end up using different variables in every topic of arithmetic aptitude. Like in the case of simple interest, we say P, T and R. Or let's talk about time and distance. What is the formula for speed? You will say S equals to D by T, where D is the distance traveled and T is the time for which the distance is covered. Well, is the distance really D? Can you say the distance traveled is D? No, it has to be some numerical value, or the time is T. So this is algebra, right? We use algebra everywhere, right? Not just in mathematics but also in other sciences. Algebra is used. We always use some letter or some symbol to denote a particular number which is unknown, let's say, right? So that's the precise or simple definition of algebra. It is simply a branch of mathematics, or it is a kind of mathematics where we use different symbols to represent unknown numbers. Now before we go ahead and discuss about various formulae and the different types of questions, let us understand a few important terms that are used in algebra. Well, this may not really be required from the examination point of view, but it's always good to know a few things, right? So let's understand algebra. Now as I've said, we have something called as variable. What is a variable? A variable is a symbol, right? A symbol or a letter which is used to denote an unknown number. It represents an unknown number or an unknown value, right? So that's a variable. So we can say, to take an example, x. Generally we use x, right? The most commonly used variable is x, right? Or it can be any other letter. We can say y or a or b, or for that matter any symbol, right? Let's say dollar, right? This is like a variable, if you understand, right? It's just a symbol, right? Or if I say, I can use the symbol of coffee, right? So a variable is nothing but a symbol which is used to represent a number. Alright. Now, what is meant by a term, right? Generally, we always talk about terms when we solve questions from algebra. So what is a term? Well, a term is nothing but a variable, right? It can be a variable, or it can be some number, or a combination of both variables and numbers, right? We generally use this word term, right, when we discuss about equations or expressions, right? The first term, second term, or the number of terms. So what is a term? It is a variable or a number, or a combination of variables and numbers. For example, this is a term. X is a term, right? Or for that matter, a number, any number. Let's say 4. 4 is also a term, right? In a given expression, when we have such different variables and constants used. Or it can be a combination of both variables and numbers. Like for example, 7y. 7y is a term, right? That's like a term, right? Or let's say 3x squared. This is one of the terms. So a term is a variable or a number which is used in a given expression, right? Now coming to expression, let's say what is an expression? What is an expression? Expression is a combination of terms, right? Expression is a combination of terms using different mathematical operators like plus, minus, multiplication or division signs there. For example, a simple expression is as follows, right? 3x squared plus, let's say, 4x plus 9 equals to, or let's not say equal to 0. It is 3x squared plus 4x plus 9. So that's an expression, right? It is a collection of terms, right? There are 3 terms here. 3x squared is one of the terms. 4x is a second term. 9 is also a term, right? As I said, a term can be a number. It can simply be a number there. So if we have got 3 terms here, 3x squared, 4x and 9. So such a collection of terms is called an expression, right? Now generally we use polynomial. I mean, this can be called as a polynomial. What is a polynomial? It's nothing but a collection of terms, right? Expression or a polynomial, right? So polynomial. And if you try to understand the word poly, right? What is poly? Poly means many, right? The root poly means many. So a polynomial is a collection of more than 2 terms, right? A collection of more than 2 terms. Again, we can classify it into different forms. For example, let's say, there's only a single term. That's called a monomial, right? A single term. There's just one single term there. It can be x, or it can be simply a number 4, or it can be 7y, right? That's called a monomial. Then there's something called a binomial. What is a binomial? Now, binomial again is a commonly used, terminology in mathematics. So binomial, 2 terms, by 2 terms, right? Then we have something called as trinomial, 3 terms, and and so on. But in general, polynomial is a collection of terms, right? More than 2 terms. So this can be called as a polynomial, right? 3x squared plus 4x plus 9. So a polynomial has got numbers, it has got variables, it has got exponents. What are exponents? Exponents are nothing but power, like x squared, x to the power of 2. So a polynomial is a collection of numbers and terms and exponents and so on. Alright. So if I have to take another example, let's say we can say 6x to the power of 4 plus 4x cube plus 9x squared plus 3x plus 18. Well, that's a polynomial, right? We have got different terms here, 6x power 4 plus 4x cube plus 9x squared, or maybe 1 or 2 of them are with a negative sign, right? Let's say this is also a negative sign. So 6x power 4 minus 4x cube plus 9x squared minus 3x plus 18. So that's collection of terms. We have got numbers, we have got variables, right? We have got exponents, x power 4, x cube, x squared, and so on. So that's called a polynomial, right? Now then there's something called a degree. What is meant by degree? Degree of a polynomial, right? Degree of a polynomial. What is degree of a polynomial? Well, if you look at this particular polynomial here, we have got different exponents: x power 4, x cube, 9x squared, 3x. Now, the highest power of the different exponents that we have in the given polynomial is called the degree of the polynomial. For example, the power of x here is 1. The power of x here is 2. Here it is 3. And here we have got 4, the power is 4. So the highest power is the degree of that polynomial. So we can say this is a 4th degree polynomial, right? This is a 4th degree polynomial. If this term 6x power 4 is not there, then we have only 4x cube plus 9x square minus 3x plus 18. This is a 3rd degree polynomial, right? If you don't have x power 4, then it becomes a 3rd degree polynomial. So the highest power of the given polynomial or of the given exponents in the polynomial is the degree of the polynomial. So simply the highest power there. I think we have covered these basic definitions also in the topic of equations. You can refer the same for in detailed explanation about such things, right? So highest power in the given polynomial is called the degree of the polynomial. So when we say this is a 4th degree polynomial, it is clear that the variable has got power 4. The highest power there is 4. Alright. So that's about a few terms there, right? Variable and term, impact, expression or polynomial and degree. And then we also talk about coefficient. What is meant by a coefficient? A coefficient is something which is along with the variable, right? Which is multiplied with the variable. For example, if you look at this, right? What is the coefficient of x squared? It is 3. What is the coefficient of x? 4 plus 4 plus 3. What is the coefficient of x cube? Minus 4. What is the coefficient of x? Minus 3. Coefficient of x squared is 9, right? So in simple words, a coefficient. What is a coefficient? It is a number in a given algebraic term, right? The number, the constant value. It can be a positive or a negative number, right? It can be a positive or a negative number in the algebraic term, right? Now what is a term? These are terms, right? These are the examples of term, right? It can be a variable or a number. So in this algebraic term, x, what is the coefficient? It is 1. In this algebraic term here, 7y, what is the coefficient? 7. It can be minus 7. If it is minus 7, then we say the coefficient is minus 7. In this algebraic term, what is the coefficient? 3. Alright. So degree is the highest power in the given polynomial and coefficient is the number that is there in each of the algebraic terms. So this is what shows the basic definition of a polynomial, right? It is just a collection of terms, collection of different algebraic terms. Now before we move ahead, let us also understand what cannot be a polynomial. There are some restrictions when it comes to a polynomial, right? If you see, we have taken different examples here, but then there are certain things which have to be followed in case of a polynomial. For example, the power of any variable in a polynomial should never be negative or fractional, right? Polynomial does not consist of fractional or negative powers. For example, let's say 3 by x plus 2. This is not a polynomial. Why? We have got x in the denominator. X in the denominator. So when it is taken to the numerator, going by the laws of exponents, laws of indices, right? What happens? This becomes 3x power minus 1 plus 2. And since it has got a negative power, it cannot be considered as a polynomial. Likewise, if it has got fractional powers, or let's say if it has got surds in terms of variables, then it cannot be considered as a polynomial. For example, let's say 3 root x plus x cube plus 4. Now this is again not a polynomial. Why? We have got a fractional power. Root x is nothing but x power 1 by 2. Or let's say we have got 5th root of x. It becomes x power 1 by 5. But a polynomial does not consist of fractional powers. So hence even this is ruled out in terms of polynomial. And what else? It cannot have variables in the division there, in the denominator, right? For example, let's say 4 divided by x plus 2 plus some other terms there. This again cannot be considered as a polynomial. What is the reason? X is in the denominator, right? It cannot come in the denominator in case of a polynomial, right? So basically these are some restrictions, right? It should not have negative or fractional powers and it should not come under division. We can have a numerical value in the denominator, that should be okay, but we cannot have a variable in the denominator, right? And also when it comes to surds, it can have irrational number, but it cannot have a surd in the form of a variable. For example, if I have an expression, let's say if you look at this polynomial, 6x power 4 minus 4x cubed plus 9x squared minus 3x plus 18 plus root 5. This should be okay. This is a polynomial because this is a constant. I mean, this is a numerical value, but it cannot have root x. Alright, so don't get confused here. It cannot have surds in terms of variables. It can have surds in terms of numbers there. Alright. So with this, we finish the basic introduction to algebra. Now that we have understood what a polynomial is, let us look at how can we perform the basic arithmetic operations like addition, subtractions, multiplication and division of two polynomials. Let's understand this with the help of a few examples. Let's say we have got two polynomials. For example, let's say the first one is 3x squared plus 5x plus 2. And the second polynomial is 2x plus 1. Alright, we have got two polynomials here, 3x squared plus 5x plus 2, and the second one is 2x plus 1. Alright, so if you look at it, we have got three terms in the first polynomial and the second one has got only two terms. So basically this is a binomial. Alright, and what is the degree of the first polynomial? The degree is 2, right? The highest power here is 2, so the degree is 2. And the highest power here is 1, right? X is nothing but x power 1. So we can say this is a first degree polynomial and this is a second degree polynomial. Now let's look at the first and the basic operation of addition, right? Addition of two polynomials. Now this is very simple. We just need to collect similar terms, add them and find out the required answer. For example, here we have 3x squared plus 5x plus 2, the first polynomial, plus the second one here is 2x plus 1. Now all we need to do is collect similar terms. If you look at it, we have got only one term of degree 2, right? Only one term where the power of x is 2. So we can directly take it as 3x squared. Now let's look at the power 1, right? 5x in the first polynomial and 2x in the second one. So add these two, 5x plus 2x. If it is minus here, we'll subtract 5x minus 2x, right? So 5x plus 2x in this case will give us 7x, right? Now go for the last type of term, right, where the power is 0. This is nothing but 2 into x power 0, right? We know that from our concept of exponents that x power 0 is equal to 1, right? Any base to the power of 0 is equal to 1. So we can say this is 2 into x power 0. This is 1 into x power 0. Or simply two constants, add them. 2 plus 1 will be equal to 3. So we say that 3x squared plus 5x plus 2 plus 2x plus 1 will add up to 3x squared plus 7x plus 3. As simple as that. Likewise, how do we subtract, right? Subtraction of the two polynomials. Let's take the same one. So 3x squared plus 5x plus 2 minus of 2x plus 1. So more or less the same, right? Arithmetic addition. Here we have to just do the subtraction. So 3x squared will remain as it is, 3x squared. Then 5x minus 2x will give you plus 3x. And 2 minus 1 will give us 1. So this is the difference of the two polynomials. Now comes the next one, multiplication. Multiplication of two polynomials. Right? So let's take the same two polynomials again, 3x squared plus 5x plus 2 multiplied by 2x plus 1. Now what is the product here? What is the product of the two polynomials? Now this is going to be different from the earlier two cases of addition and subtraction. What do we do here? Each term in the first polynomial has to be multiplied with each term in the second polynomial. We know what a term is, right? A term is a variable or a constant or a combination of a variable and a constant, right? There are three terms here and here we have got two terms. So each term of the first polynomial gets multiplied with each term of the second polynomial. Then so the first term gets multiplied with the two terms in the second polynomial, then the second term gets multiplied with the two terms of the second polynomial, and then the third term of the first polynomial gets multiplied with the second term, two terms of the second polynomial. So just multiply each term of the first polynomial with each term of the second one. Let's do that. So let's multiply 3x squared with 2x and 1. So what is 3x squared into 2x? 3x squared into 2x. Now this is basic algebra, right? 3 into 2 is 6. X squared into x. The bases are equal and in multiplication form. The powers have to be added, right? Laws of exponents. So 3x squared into 2x will be 6x cubed. This is going to be 6x cubed, right? So multiply with 2x. Now multiply 3x squared with 1. What is 3x squared into 1? 3x squared as it is. Plus, now comes the second term, 5x. Multiply 5x with both the terms of the second polynomial. So 5x into 2x. 5 into 2 is 10. X into x, x squared. So this will give us 10x squared. Plus 5x into 1 will be 5x. And now comes the last term here, which is a constant, right? A number. 2 should be multiplied with 2x plus 1. So 2 into 2x is 4x and 2 into 1 is 2. Now what do we do? Now that we have multiplied each term of both the polynomials, we have to collect similar terms so that this looks to be a little simpler, right? So we have only one term with x cubed, so this will be equal to 6x cubed plus, look at the terms with power 2, 3x squared and 10x squared will give us 13x squared. Now comes power 1, 5x and 4x will give us 9x, and finally we have the constant 2. So the product of these two polynomials will be equal to 6x cubed plus 13x squared plus 9x plus 2. And now let us see how do we divide two polynomials. I'll just clear this part here and we'll see how can we divide the two polynomials that we have taken. So let's look at the division of these two polynomials, right? We'll divide 3x squared plus 5x plus 2 by 2x plus 1, right? So this is a regular division process. Let's see how it works. You take 2x plus 1 as the divisor and write 3x squared plus 5x plus 2 in place of dividend. Now, how do we proceed with the division here? Let's look at it. We just need to take the first term of divisor. Here we have got two terms in the divisor. Now take the first term, which is 2x. We should multiply 2x with some other term such that we obtain 3x squared. Are you able to follow? This is going to be the quotient, right? And we'll get the remainder. We may or may not get a remainder towards the end of this division. Now how do we decide the terms of the coefficient? The first term of the coefficient, when it gets multiplied by 2x, should give us 3x squared. Are you able to follow? Or to look at it in another way, we can say what should be multiplied by 2x so that we get 3x squared. So whatever the term that gets multiplied by 2x will be the first term of the quotient, right? So 2x into what will be equal to 3x squared, right? 2x into, let's say, some question mark is equal to 3x squared. So what is this question mark going to be? 3x squared divided by 2x, which is nothing but 3 by 2x. And see, you need not do all this stuff on paper while doing these divisions. I'm just trying to explain it to you in detail, but you very well understand that 2x has to be multiplied by 3x by 2, so that 2 and 2 gets cancelled and x into 3x becomes 3x squared. So the first term of the quotient here will be 3x by 2. Now that we have got the first term of the quotient, let's multiply each term of the divisor with the quotient. So 2x into 3x by 2. 2x into 3x by 2 will be 3x squared, right? The idea here is to map with the first term here, 3x squared and 3x squared. So 2x into 3x by 2 will be equal to 3x squared. Now the second term of the divisor should be multiplied with the first term of the quotient. So 1 into 3x by 2. What is 1 into 3x by 2? It is 3x by 2. So plus 3x by 2. Are you able to follow? 2x into 3x by 2 is 3x squared. 1 into 3x by 2 is 3x by 2. Now, like we do in the regular division, subtract whatever we have got from the given dividend. So anyway, plus 3x squared and minus 3x squared gets cancelled. Let's look at the second term here. 5x minus 3x by 2. 5x minus 3x by 2. Or 5x minus 1.5x. That will be equal to 3.5x, right? 5 minus 1.5 is 3.5, which can be taken as 7 by 2, right? So 5x minus 3x by 2 is going to be 7x by 2. 7x by 2. And let's take the third term, right? What do we get? 7x by 2 plus 2. Alright. Basically this is 0 here. So 2 minus nothing. 2 minus 0 will give you 2. Now comes the next term, right? What should be the next term of the quotient here, right? What is going to be the next term of the quotient? What do we do now? See, this is the new dividend that we have got, 7x by 2 plus 2. Now we need to multiply 2x with some term such that we get 7x by 2. 2x into what? Like what we have done in the earlier case. 2x into what gives us 3x squared. Now 2x into what gives us 7x by 2. 2x into what will be equal to 7x by 2? I think 2x into 7 by 4. Right? When you multiply 2x with 7 by 4, the 2 in the numerator and 4 in the denominator gets cancelled. So what are we left with? 7x by 2. Right? So 2x into 7 by 4. Right? Understand, there is not going to be any variable in the second term here. Right? Because if we take x here, 2x into 7 by 4x will become 7 by 2 x squared. But what we need here is 7 by 2 x. Alright, so we just need to map in such a way that we get the first term, right? So 2x into 7 by 4. 2 and 4 gets cancelled. So we are left with 2 in the denominator, and 7 into x is 7x. So 7x by 2. So 2x into 7 by 4 is equal to 7x by 2 plus 1 into 7 by 4. 1 into 7 by 4 is 7 by 4 as it is. Now again let's subtract, right? Subtract, what do we get? 7x by 2 and minus 7x by 2 gets cancelled. 2 minus 7 by 4. What is 2 minus 7 by 4? 1 by 4. 2 minus 7 by 4 is equal to 1 by 4. And this is the remainder. Are you able to follow? This is going to be the remainder. Right? Now whatever you multiply 2x with, we cannot get 1 by 4. Now again we cannot take 2x into, let's say 2x into 1 by 8x. If you take 1 by 8x here, 2x into 1 by 8x or 2x by 8x will be equal to 1 by 4. But that should not be taken here, right? We should stop, only the positive powers have to be considered. So simply we say 2x plus 1, and here we have got 3x squared plus 5x plus 2 as the divisor and the dividend respectively. The idea here is to multiply the terms or the first term of the divisor with some term in such a way that we get the first term of the dividend, and then do the subtraction. Again we are left with 7x by 2 plus 2. Again multiply the first term of the divisor with some term, 7 by 4 in our case, such that we get the first term of the new dividend. And then when we subtract, we are left with 1 by 4. So we can say 3x squared plus 5x plus 2 when divided by 2x plus 1 will give us a quotient of 3x by 2 plus 7 by 4. And there is a remainder 1 by 4. Alright. So this is how we can divide two different polynomials, right? This is how polynomials can be divided. Now that we have learned how to divide two polynomials, let us learn the remainder theorem. Now the remainder theorem states that if f of x is a polynomial of degree greater than or equal to 1. Now we know what a polynomial is. It is a collection of terms in some variable, right? So here the variable is x. Right? So in the variable x, if f of x is a polynomial of degree greater than or equal to 1 and alpha is any real number, right? Alpha is some real number. Then if we divide the polynomial f of x by x minus alpha, right? The polynomial f of x, the same polynomial, when it is divided by x minus alpha, the remainder will be equal to f of alpha. Are you able to follow? So there is a polynomial f of x and there is a real number alpha. This polynomial, when we divide by x minus alpha, we know that we get some remainder, and which can be verified using the division method that we have seen earlier. But the remainder theorem states that instead of doing the long division to find out the remainder, we can directly say that the remainder of that division is going to be f of alpha. Now what is meant by f of alpha? See, f of x is the polynomial where x is the variable. In place of the variable x, we need to substitute the real number alpha. Right? So wherever we have x in the polynomial, just replace that with the number alpha. Whatever simplification we get, the number there is going to be the remainder. Let us understand this with the help of an example. Let us say there is a polynomial f of x. Let f of x be equal to let's say 2x squared plus 5x minus 1. So this is a second degree polynomial, right? The degree should be greater than or equal to 1. So a second degree polynomial, 2x squared plus 5x minus 1. And now let's consider some real number alpha. Let's say alpha is equal to 3. Right? Alpha, the real number alpha is equal to 3. Now the theorem states that when this polynomial is divided by x minus 3, x minus alpha, the remainder is going to be f of alpha. So what happens? You divide 2x squared plus 5x minus 1. Divide this by x minus 3, x minus alpha. What is the remainder? The remainder is equal to what is the question? What is the remainder? The remainder will be f of alpha, f of 3. So as you see here, we do not have to do the long division to find out what the remainder is. We can simply substitute 3 in place of f of x and get the remainder. So what is f of 3? F of 3 will be equal to 2x squared, 2 into 3 squared, plus 5x, 5 into 3, minus 1. So simply substitute 3 in place of x. So let's simplify this. 3 squared 9, 9 into 2 is 18, 18 plus 5 3 is 15 minus 1. So 18 and 15, 33, 33 minus 1 will be equal to 32. So we can say the remainder of this division is going to be 32, right? F of 3 is equal to 32. So this is how we can find out the remainder when we divide a polynomial with the other polynomial without doing the actual division. Having learnt about the remainder theorem, let us now look at the factor theorem. The statement says that if f of x is a polynomial of degree greater than or equal to 1 and alpha is any real number such that f of alpha is equal to 0. Right? So like in the earlier case, f of x is a polynomial of degree greater than or equal to 1 and alpha is a real number. But the condition here is f of alpha is equal to 0. In such a case, x minus alpha will be a factor of the polynomial f of x, right? Then x minus alpha is a factor of the polynomial f of x. Conversely, we can also say that if x minus alpha is a factor of f of x, then f of alpha has to be 0, right? If x minus alpha is a factor of f of x, then f of alpha has to be 0. If you observe the latter part of the statement here, it says if x minus alpha is a factor of f of x, then f of alpha equal to 0. This corresponds to the remainder theorem. We very well know that as per the remainder theorem, if a polynomial f of x is divided by x minus alpha, then the remainder is f of alpha. Here, since x minus alpha is a factor of f of x, what do you mean by factor of f of x? It means it divides f of x completely. There is no remainder. Yes or no? X minus alpha is a factor of f of x, which means it is completely dividing f of x, or f of x is completely divisible by x minus alpha. When it is completely divisible, there won't be any remainder. That is the reason the remainder f of alpha will be equal to 0, since the remainder will be 0. Yes or no? For example, we say that 3 is a factor of 9. What does it mean 3 is a factor of 9? When 9 is divided by 3, the remainder is 0. Here, x minus alpha is a factor of f of x. If x minus alpha is a factor of f of x, there shouldn't be any remainder, which means the remainder as per the remainder theorem is f of alpha. It should be 0. As there is no remainder, they should be equal to 0. So this is how the remainder theorem and the factor theorem are interlinked to each other. Alright, so the statement here says let f of x be a polynomial and let alpha be a real number. Now if x minus alpha or if f of alpha is 0, the direct statement here is f of alpha is 0, then x minus alpha will be a factor of f of x. So if the remainder is 0, it means it is a factor, or if it is a factor, then the remainder has to be 0. This is what is meant by the factor theorem. Let us understand this with the help of an example. Let's consider some polynomial. For example, let's say f of x is equal to x squared minus 3x, x squared minus 3x minus 4, right? So here is the polynomial f of x, a second degree polynomial, x squared minus 3x minus 4. Now let's consider the value of alpha, right? But alpha should be such that f of alpha is 0, right? When you substitute alpha in place of x, it should be equal to 0. So what can be the root of that equation? I'm just trying to give you the value of alpha such that f of alpha is 0, right? Otherwise it will be directly given. Just to prove the theorem, I'm doing the actual calculation here. So if I look at the roots there, I think it should be 4, right? Let's say alpha equals to 4, right? Alpha is equal to 4. Now let's find out what is f of alpha. F of alpha is equal to f of 4, which must be equal to 4 squared minus 3 into 4 minus 4. How much is this? 16 minus 12 minus 4 is equal to 0. Now that f of 4 is equal to 0, we can say x minus alpha or x minus 4 is a factor. Is a factor of f of x. Right? So this is the factor theorem. Or if it is given that x minus 4 is a factor of f of x, then f of 4 should be equal to 0. The remainder has to be 0. So this is the factor theorem. Let us now look at a few methods of simplifications based on fractions that can be helpful in answering the questions from algebra and other topics like surds, indices, etc. Generally, when we have two fractions that are in proportion, we can apply different methods of simplification to arrive at the correct answer much faster. So let's consider two fractions that are in proportion and then look at what these different methods are. So let's say there are two fractions, A by B and C by D. Right? So these are the two fractions. Now what does it mean when we say that the two fractions are in proportion? Basically they are equal, right? The ratio of A to B is equal to the ratio of C to D, alright, which has been covered in detail in the video of ratios and proportions. So here we have got the concept of proportionality, right? A is to B is equal to C is to D. Now let's see what kinds of operations can be performed on these two fractions to arrive at different relationships which can be helpful in answering questions from various topics easily. Let us first try to cross multiply the numerators and denominators. Basically, let us take the numerator of the first fraction to the second denominator of the second fraction and the denominator of the first fraction, second fraction to the numerator of the first fraction. Likewise, let us just interchange the numerator and denominator of the second fraction and first fraction respectively. Basically a kind of cross multiplication. So what do we get when we do that? We simply say that D by C will be equal to B by A. Alright, D by C is equal to B by A. Or you can say that B by A is equal to D by C. Now what does it look like, right? A by B, the fraction A by B has become B by A and the fraction C by D has become D by C. So basically reciprocal of the individual fractions, which means if A by B is equal to C by D, then we can say that B by A will be equal to D by C. This is what we have got here, B by A equals to D by C. And this operation or this relationship is known as invertendo. Right? This is called as invertendo. So while simplifying questions from algebra, we can sometimes apply invertendo and try to simplify the given question much faster. Let us now try a different operation, right? For example, let us simply take A to the denominator of the second fraction and D to the numerator of the first fraction. So what do we get? We'll get D by B equals to C by A. D by B equals to C by A. Or we can say A by C equals to B by D, right? Different ways of looking at it. A by C equals to B by D. What is this operation known as? A by C equals to B by D. This is known as alternando, right? This is alternando. So basically we are alternating their numerators and denominators of the opposite fractions. So this is called alternando. So as you see here from the first equation, the basic equation, that is A by B equal to C by D, we have got two new relationships, right? One is called invertendo and the second one is called alternando. So let us now look at the next relationship which can be obtained from equation 1. Let us add 1 on both the sides of the given equation, right? Plus 1 on both the sides, which does not change the equation. So what do we get? A by B plus 1 equals to C by D plus 1. Alright, so we are adding 1 to equation number 1. Now let's simplify this. What do we get? A plus B by B equals to C plus D by D. Basically D is the LCM here. So we get A plus B by D and D is the LCM here, C plus D by D. This is a new relationship that we have obtained, right? So when we say that A by B equals to C by D, we can also conclude that A plus B by D will be equal to C plus D by D. So basically the denominators get added to the numerators, right? And we say that A plus B by B equals to C plus D by D. And this operation is known as componendo. I'm sure all of you have heard about this relationship componendo. Let us now go for another relationship. Let us subtract 1 from equation number 1, right, on both the sides. So what do we get? A by B minus 1 equals to C by D minus 1. And then simplifying further, what do we get? A minus B by B equals to C minus D by D. And this is the new relationship which is known as dividendo. right? So we can say a minus b by b equals to c minus d by d. So basically here we are subtracting the denominators from the numerators and we get this relationship called dividend. How do we obtain this? Just subtract 1 on both the sides. So when we are actually simplifying the questions, we need not add 1 or subtract 1 on both the sides. We can simply remember these identities called componendo and dividendo and go ahead and perform the operation there. Now we have one last relationship here, which is obtained by combining both componendo and dividendo. Alright, we have already got two different relationships here, componendo and dividendo. Now let's find out the next one, which is a combination of componendo and dividendo. What do we do here? Divide these two equations. Let's say this is equation number 2, right? And here we have equation 3. So let's take equation number 2 by equation number 3. So what do we get? We can say a plus b by b whole divided by a minus b by b equals to c plus d by d divided by c minus d by d. Alright? Now, this when simplified further, what happens? B and B anyway gets cancelled. D and D also gets cancelled here. So what are we left with? A plus b by a minus b equals to c plus d by c minus d. And this relationship is known as componendo dividendo. Alright, now while solving various questions, you may apply any of these relationships: invertendo, alternando, componendo, dividendo, or componendo and dividendo, to see if you can get the answer really quick and in a much simpler manner. And here is the most important part from this topic of algebra, that is the various algebraic identities or the algebraic formulae that will help us in solving the questions from this topic. So I've listed down most of the algebraic formulae here on the board. All you need to do is make a note of it and make sure that you remember and learn these formulae by heart. Remember guys, if you forget any of these identities, then solving the question may get complex and you may end up wasting a lot of time by solving it in a traditional method. So make sure that you learn all the formulae by heart so that you can solve the questions much faster and in a simpler way. So let us quickly run through this by the time you copy it. Now I'm sure all of you know most of these identities here, right? Look at the first one. A plus b the whole square is equal to a squared plus 2ab plus b squared. And a minus b whole squared will be a squared minus 2ab plus b squared. Now, not just what is given here is important, but also the other identities that can be made from the given ones. For example, a plus b whole square is equal to a squared plus 2ab plus b squared. Now, here I can say that a square plus b square will be equal to a plus b whole square minus 2ab, right? If this plus 2ab goes on the other side, it becomes minus 2ab. So we can say a square plus b square is equal to a plus b whole square minus 2ab. Likewise, in the second case, a minus b whole squared is a squared minus 2ab plus b squared. So here we can say a squared plus b squared is a minus b whole square plus 2ab, right? So you need not remember every part of it. If you know the basic one, that is a plus b whole square equals to a square plus 2ab plus b square, then while solving the question, if required, you can say a square plus b square equals to a plus b whole square minus 2ab. Likewise here, a square plus b square equals to a minus b whole square plus 2ab. Alright? And now the next one, that is a plus b the whole cube. What is it? A cube plus b cube plus 3ab into a plus b. And if we simplify this part, we get a cube as it is, then 3ab into a is 3a squared b, 3ab into b is 3ab squared plus b cube. So there are two ways of looking at it. A plus b whole cube can be taken as a cube plus b cube plus 3ab into a plus b, or a cube plus 3a square b plus 3ab square plus b cube. And then a minus b whole cube, which is in line with what we have discussed earlier. All we need to do here is, instead of plus b, you take minus b in the expansion. Alright, so if you know what is a plus b whole cube, then a minus b whole cube is known by default, right? What do we do? See, plus b becomes minus b. So in the complete expansion, wherever we have plus b, just replace with minus b. So a cube as it is. Now plus b cube. If you take minus b cube, it will give us minus b cube, right? Understand, minus into minus into minus will result in a minus sign. If it is b squared, then we can take it as minus b whole square, which again remains as b square. But in this case, b cube becomes minus b cube. Plus 3a into minus b will give you minus 3ab. A plus b becomes a minus b. Alright, so just replace plus b with minus b. Likewise, in the second part of it as well, a cube is as it is, plus b becomes minus b. So plus 3a square b becomes minus 3a square b. Plus 3ab square. Now look at this. B should be replaced with minus b. Minus b the whole square is b square. So plus 3ab square remains plus 3ab square. And plus b cube becomes minus b cube. So just remember one and you will get the other one by replacing plus b with minus b. Next one, a cube plus b cube. Now again, if you look at it, we have got a cube plus b cube from this formula, right? A cube plus b cube can be taken as a plus b whole cube, and this part goes to the other side. So it becomes minus 3ab into a plus b, like what we have done in case of a plus b whole square. A square plus b square is a plus b whole square minus 2ab. Likewise, a cube plus b cube is a plus b whole cube minus 3ab into a plus b. And if you try and simplify this expansion here, we can also take it as a plus b into a squared minus ab plus b squared, right? So remember both of them, right? This is from the previous one, but even this expansion is important. A cube plus b cube can be taken as a plus b into a squared minus ab plus b squared. So depending on the requirement, we may use either this expansion or this one and simplify the given question. And again, you know that a cube plus b cube is equal to a plus b into a square minus ab plus b square. So in some cases, we may say that a plus b is equal to a cube plus b cube divided by, now this part here, the second factor goes in the denominator. So a cube plus b cube divided by a square minus ab plus b square will give us a plus b. And likewise, a cube minus b cube. So we know that a cube minus b cube is a minus b whole cube plus 3ab into a minus b. And the other way of taking it is a minus b into a square plus ab plus b square. Again, here we can say a minus b is a cube minus b cube divided by a square plus ab plus b square. Understand, you have to remember each of these expansions by heart, right? What would be required in the exam is not known to us, right? If you remember each one of them, then based on the requirement, you can use the correct expansion and arrive at the answer really quick, okay? Then the next one, I think one of the most important algebraic identities, right? A squared minus b squared is a plus b into a minus b, or a plus b into a minus b is a squared minus b squared, right? So very, very useful, not just in algebra, but various other topics as well, right? In fact, for doing simple multiplications, right? We have learned this in speed maths, that a plus b into a minus b equals to a squared minus b square is pretty useful in doing certain types of multiplications, okay? And we'll also see a lot of applications on this expansion while solving questions from algebra. And this also was used in rationalizing, right? If you remember surds and indices, or if you go to the video of surds and indices, you'll find the application of this expansion, right? This is used in identifying what should be the rationalizing factor for a given fraction. Then comes the next one, a plus b plus c whole squared, right? What will it be? A squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. Or if we take 2 common here, we can say ab plus bc plus ca. So a squared plus b squared plus c squared plus 2 times ab plus bc plus ca. Alright? And a plus b plus c the whole cube, right? Now what is a plus b plus c the whole cube? It can be taken as a cube plus b cube plus c cube plus 3 times of a plus b into b plus c into c plus a. Alright, so a plus b plus c the whole cube is a cube plus b cube plus c cube plus 3 times of a plus b into b plus c into c plus a. And as I said, this is one way of taking it. You can simplify the remaining part of it. However, a cube plus b cube plus c cube will remain as it is. You can multiply these 3 terms here. You will get a lot of terms, then collect the similar terms together and you will get another expansion for a plus b plus c whole cube, right? For example, if I have to show you, let's only focus on this part here, right? This part of the expansion. So we can say a plus b plus c the whole cube will be equal to a cube plus b cube plus c cube plus, instead of taking it, when you simplify, it will come out to be 3ab squared plus 3a squared b plus 3 ac squared plus 3a squared c plus 3 bc squared plus 3 b squared c plus 6 abc. Now if you ask me how do you know that, I've just learnt it by heart. You just need to mug it up. So either take this, or I'm not trying to say that you have to expand this in the exam. All you need to do is learn it and use if required. So a plus b plus c the whole cube can be taken as a cube plus b cube plus c cube plus 3 times of a plus b into b plus c into c plus a, or 3a square b plus 3ab square plus 3c square a plus 3ac square plus 3bc square plus 3b square c plus 6abc. Alright? And now the last one here, a cube. Now this is important, right? This again is a very important application. While solving questions from algebra, we would use this depending on the requirement, right? So a cube plus b cube plus c cube minus 3abc, a very important identity as I've mentioned earlier, right? A cube plus b cube plus c cube minus 3abc will be equal to a plus b plus c into a squared plus b squared plus c squared minus ab minus bc minus ca. Or the other way of taking it is half of a plus b plus c into, now we have square brackets here, within that we have a minus b the whole square plus b minus c the whole square plus c minus a the whole square. And you can verify, in fact, this part of it, if you observe, this part of it has been expanded as, this dotted part here has been expanded as half of, you see a plus b plus c is as it is, we have got half additionally here outside, half of a minus b the whole square plus b minus c the whole square plus c minus a the whole square. What happens, just try to verify, a minus b whole square, a square plus b square minus 2ab, b square plus c square minus 2bc, c square plus a square minus 2ca. So we have got 2 times a square here and a square here, b square and b square, c square and c square. But what we need is only a square plus b square plus c square. Are you able to follow? So we take that 2 common outside, so we get 2 times of a square plus b square plus c square and divide by 2, so that 2 and 2 gets cancelled. And what happens the remaining part? We get minus 2ab minus 2bc minus 2ca, but what we need only minus ab minus bc minus c. So again that complete 2 is taken outside common and divided by 2. So half of this expansion will give us what we have, what we had earlier, right? So a plus b plus c into a square plus b square plus c square minus ab minus bc minus c, or half of a plus b plus c into a minus b the whole square plus b minus c the whole square plus c minus a the whole square. So nothing to worry about, just copy and learn it by heart. And then from this I would also like to draw your attention to one very important point, right? While solving a few questions from algebra, you would find the application of this one. If you look at this identity here, a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. Now if at all a plus b plus c is equal to 0, let's say the sum of the 3 variables a plus b plus c is equal to 0, there will be some numbers, right? The sum is 0, a plus b plus c is equal to 0. Then what happens? If this part becomes 0, then whatever is multiplied also becomes 0. So the complete right hand side becomes 0. Alright? One of the terms is 0. A plus b plus c is 0. So a plus b plus c is 0 into whatever it is will become 0. Even in the second case, if a plus b plus c is 0, you multiply with whatever you have here, it will result in a 0. So if a plus b plus c is equal to 0, what happens? We get a cube plus b cube plus c cube minus 3abc equals to 0. Or we can say a cube plus b cube plus c cube equals to 3abc. So this again is an important identity which we derive from the last one here, right? I'll just try to put it here. If a plus b plus c equals to 0, right? If this part is 0, a plus b plus c equals to 0, then what do we get? A cube plus b cube plus c cube equals to 3abc. Alright, so here there is a condition if you observe. If a plus b plus c is 0, only then we can say a cube plus b cube plus c cube equals to 3abc, right? Very popular question and a frequent question is based on this concept, right? This point of a plus b plus c equals to 0. So I think most of the identities are here. You can just copy them and make sure, as I've said, you must remember each one of them by heart, and it must be available on your fingertips for you to solve different types of questions from algebra. So now that we have covered all the basics required for solving different types of questions from the topic of algebra that are generally asked in various competitive exams, let us solve a few questions. And we shall start with a previous year's question from the SSC CHSL exam. So let's look at the question first. It says if x plus y plus z is equal to 6 and x squared plus y squared plus z squared is equal to 20, then find the value of x cube plus y cube plus z cube minus 3xyz. And we have got 4 answer options here: 64, 70, 72 and 76. So how do we answer such question? Well, all we need to do is look at the given equation x cube plus y cube plus z cube minus 3xyz and check if it can be obtained from any of the identities that we have learned earlier. Now if you recollect, x cube plus y cube plus z cube minus 3xyz is one of the identities that we have taken in the given list of algebraic identities, right? It can be expressed as follows: x cube plus y cube plus z cube minus 3xyz will be equal to x plus y plus z into x squared plus y squared plus z squared minus xy minus yz minus zx. Right? If you remember, there was an expression that we have learned, right? A cube plus b cube plus c cube minus 3abc will be equal to a plus b plus c into a squared plus b squared plus c squared minus ab minus bc minus ca. And there was an extension to this, which was if a plus b plus c equals to 0, or in this case if x plus y plus z is equal to 0, then what happens? X cube plus y cube plus z cube will be equal to 3xyz. However, the second part of it is not required. All we need to have is find out the value of x cube plus y cube plus z cube minus 3xyz. Now if you look at the right hand side of this equation, we have x plus y plus z into x squared plus y squared plus z squared minus xy minus yz minus zx. In the given question, we already know the values of x plus y plus z, which is 6, and x squared plus y squared plus z squared, which is equal to 20. So x plus y plus z will be equal to 6, and x squared plus y squared plus z squared is 20. But we have no idea about what is minus xy minus yz minus zx, or if we take minus common here, we get xy plus yz plus zx. So let us first focus on finding out the value of this part, xy plus yz plus zx. Now how can that be done? Let's see. We know the expansion of x plus y plus z the whole square, right? How do we take x plus y plus z whole square? X plus y plus z whole square will be equal to x squared plus y squared plus z squared plus 2 times of xy plus yz plus zx, right? We have taken in terms of ABC when we had looked at the various identities, but here we have x, y and z, but that doesn't really matter, right? A variable is a variable. You can use any letter of the English alphabet to represent it. Now if we substitute x plus y plus z equals to 6 and x squared plus y squared plus z squared equals to 20 in this equation, we'll be able to find out what is xy plus yz plus zx. So let's do that. So this will be 6 squared equals to x squared plus y squared plus z squared is 20 plus 2 times of xy plus yz plus zx. So from this we can say 6 squared, 36 minus 20. 36 minus 20 is 16. 16 divided by 2 will give us 8. So we can say xy plus yz plus zx is equal to 16 by 2, which is 8. Now we have got all the required values here: x plus y plus z, x squared plus y squared plus z squared, and minus of xy plus yz plus zx. Let's substitute and find out the required answer. So we can say finally the equation again here: x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z, which is 6, into x squared plus y squared plus z squared, 20, minus of, we are taking xy plus yz plus zx, which is 8. So minus of 8. So 6 into 20 minus 8. 20 minus 8 is 12. 12, 6, 72. So the answer for this given question has to be 72, which is option C. So that's how, if you remember all the given algebraic identities properly, and if you use them at the right place in the right form, then answering such questions would become really very simple. And you can also cut down the number of steps here. We need not write all these equations again on paper and waste our time. We can just put in the numerical values and find out the required answer. So this is one way of arriving at the required answer, right? We just need to use the correct algebraic identity and substitute the given values so that we arrive at the required answer. But what if we have no idea about what the expansion is, right? Or let's say if we forget that x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into x squared plus y squared plus z squared minus xy minus yz minus zx. Right? So what do we do in such a case? Can we arrive at the required answer? Can we get the correct answer even without knowing this equation? Well, yes. May not be in all the cases, but there are a few cases in which we can find out the required answer even without knowing the formula or the algebraic identity. How do we do that? Well, we just need to go ahead and do random substitution. See, we have got two equations here, x plus y plus z equals to 6 and x squared plus y squared plus z squared equals to 20. And there are no restrictions with respect to the values of x, y and z, right? They can take any values such that the sum of the three values has to be 6 and the sum of its squares should be 20. So we can try out with different possible solutions or different possible values of x, y and z and see if we are able to find out what x, y and z is, right? If we are able to get x plus y plus z equals to 6 and the sum of their squares as 20, then we know those individual values. And once we get the individual values of x, y and z, just substitute in the given equation and we'll get the required answer. Now there may be multiple solutions, right? It need not be only one unique solution that x, y and z has got. There may be multiple solutions. But understand, in such cases, whichever solution you go ahead with, final answer has to be 72 or the final answer will be same in all the cases. So let's try and find out what are the values of x, y and z. But before we do that, let me repeat and remind you again that this may not be possible in all the questions from algebra. But yes, there are fair chances that we can do this in most of the questions, if not all the questions. So let's see what can be the possible solution for x, y and z. Now here if you look at it, sum is 6 and the sum of their squares is 20. Let's assume that all the values are positive. X, y and z all are positive values. Now, and also we can go ahead and assume any of these values to be 0 because there is no condition with respect to the value of x, y and z. We can say that x is 0 and y also is 0. So z is equal to 6 or y and z are equal to 0. X will be equal to 6. But that doesn't help us in the second equation, right? If x is equal to 6, 6 squared should be 36 plus 0 square plus 0 square. It is coming out to be 36, but the right hand side is 20, hence it is not balanced. But however, we can take one of those values as 0 if required, or if that really helps us in finding out the solution. So what do we do? Just look at this point, x squared plus y squared plus z squared equals to 20, right? Now if you look at the two equations, I think verifying this equation is important, right? If we are able to balance this equation, then we can use the values of x, y, z and see if we can get 6 or not, right? Now, since we have assumed that each value is positive, let's say each one of them is 1. So 1 squared plus 1 squared plus 1 squared will be 3. Is not the right solution, right? If we take each one of them as 2, 2 squared plus 2 squared plus 2 squared, what do we get? 4 plus 4 plus 4, 12. If we take each one as 3, 3 squared plus 3 squared plus 3 squared, that becomes 27. But what we have here is just 20. So, that's like just trying out with various possibilities. Now the point that we need to understand here is, none of x, y and z can be more than 5. Why is it so? The moment we take x equals to 5, 5 squared will become 25. And definitely y square and z square are going to be positive. So 25 plus a positive number plus another positive number cannot give us 20. So clearly the first idea that we need to apply here, or that we should probably get while answering this question, is none of these values can be more than 5, right? Maximum it can be 4, and we are assuming that these are integer values. Let's not complicate the solution by taking up some fractional values or other numbers. Let's assume these are all integers. So maximum it can be 4. It cannot be more than 4. Now let's say x equals to 4. If x is 4, x squared becomes 16. But we need 16 and how much more? 4 more. How can we get 4 using y and z? If we take 1 and 1, we get only 2. 1 square plus 1 square is 2. So 16 plus 1 plus 1 is only 18. But we need 20. Can we take 2 and 2? No, that doesn't help, because 4 plus 4 plus 16 will become 24. 16 plus 4. But can we take y as 4, y as 2 and z as 0? Yes. If you take x squared, 4 squared, 16, y squared, y is 2, 2 squared, 4, z is 0. So 16 plus 4 plus 0, 20. And that also satisfies the first equation, right? 4 plus 2 plus 0. 4 plus 2 plus 0 is 6. 4 squared plus 2 squared plus 0 squared is 20. 16 plus 4 plus 0 is 20. That's it. We have got one of the possible solutions. X is equal to 4, y equals to 2 and z equals equals to 0. Well, I understand. The question that now comes to your mind is, how long should we try for such a solution? Well, you know that in competitive exams we have about 36 to 40 seconds per question, or let's say we can spend at best a minute for these kind of questions. So just give it a try. That's like trial and error. There is no direct solution to find out what the values of x, y and z are, right? It's all trial and error. So just give it a try, maybe 2-3 times or up to 15-20 seconds. If you get the solution, well and good. Otherwise, just skip the question and move to the next one. However, we are assuming that we don't know what the equation is. So in such a case, you just try for 15-20 seconds. If you get the solution, fine. Otherwise, move to the next one, right? And we may get different solutions. As I said, I am taking x as 4, y as 2 and z as 0. You may take x as 0, y as 2 and z as 4, or 0, 4 and 2, right? It can be in any order, right? It has to balance the two equations. It has to satisfy the given two equations. Now let's substitute these values in the given equation here. X cube will be equal to 4 cube plus y cube is 2 cube, z cube is 0 cube. Minus 3 into x into y into z is anyway going to be 0. Since z is equal to 0, this complete term here becomes 0. So 4 cube 64 plus 2 cube is 8. 64 plus 8 72. 72 plus 0 is equal to 72. Is that what we have got earlier? Yes, 72 it is. So this is how we can either go ahead with the algebraic identities, usage of those identities that we have learned and simplify to get the required answer, or a random substitution, just keeping in mind the given two equations, and once we get the right values of x, y and z which satisfies the given equation, then we can just simply substitute it here and find out the required answer. You need not worry about different possible solutions there. Let me repeat this again, right? If you are getting one solution which satisfies both the equations, and if there are no other conditions involved in the given question, then you can just simply substitute and find out the right answer. Need not worry about the other solutions, right? For example, there may be some other solution for x, y and z. Whatever be the solution, the final answer has to be 72. So simply try with the algebraic identities if you know the correct one, or go ahead and see if a random solution or random substitution helps you arrive at the right answer. Let us now take the second example, and even this one here is a previously asked SSC CGL exam question. Now it goes as follows. If a squared plus b squared plus c squared equals to 2 times of a minus b minus c minus 3, then find the value of 2a minus 3b plus 4c. And the options here are 3, 1, 2 and 4. Well, this really is a typical one. I mean, if you look at the given expression or equation here, a squared plus b squared plus c squared equals to 2 times of a minus b minus c minus 3. That doesn't really correlate with any of those identities that we have looked at, right? And also, the required value is not a very general one, right? It's like 2a minus 3b plus 4c. So, doesn't look like it will match with any of the identities that we have seen earlier. So let's try and see if we can get the solution of A, B, C directly by using some logic, or we'll have to go with some other method of answering this question. Now if you look at the left hand side of the given equation, it is A squared plus B squared plus C squared, which definitely is going to be a positive value. Since each one of the variable here is squared, we get a positive term, right? A square can never be negative. So this is going to be a positive number, which means if you look at the right hand side now, we have got two terms. The first term here is 2 times of a minus b minus c, and the second term is 3, right? In between we have got a negative sign. So if the left hand side is positive, it is obvious that the right hand side should also be a positive number, right? In fact, it has to be equal to what we have on the left hand side. But then we can at least go ahead and say that the first term, that is 2 times of a minus b minus c, should be greater than 3. Right? It has to be greater than 3. 2 times of a minus b minus c has to be greater than 3. Only then this can become positive. And that's just one way of trying to get some idea about A, B and C, right? I don't say that this is the right solution or this is how you should proceed, but when you are trying with some random numbers there, you just can't substitute anything you want, right? Like in the earlier case we have seen that x squared plus y squared plus z squared was equal to 20 and x plus y plus z was equal to 4. So there we know that any value there cannot be more than 4, because the moment it goes beyond 4, what happens? We get x square as 25, and y square and z square has to be positive. So the sum of these three cannot be 20. So that we just try to establish on what can be the range of the given number. So going by that logic, what do we get? 2 times of a minus b minus c has to be greater than 3, or a minus b minus c has to be greater than 3 by 2, right? But then even this is not really comfortable, right? What values should we substitute there? And it has to balance with a squared plus b squared plus c squared, whatever we go and get on the right hand side. So I think going by substitution is not really the method here, right? And if you take some trivial solutions like a, b, c equal to 0, even that doesn't satisfy. If a, b and c all are 0, left hand side is 0. But what about the right hand side? This term becomes 0, but we have minus 3. So 0 doesn't help. If you try with 1, let's say, this is going to be 3. 1 plus 1 plus 1, 3. But this will be negative, right? 1 minus 1 is 0. 2 into minus 1, minus 2, minus 3, minus 5. If you try with 2, 4 plus 4 plus 4 is 12. But here again we get a negative number. So clearly, going by trivial solutions or some logic like this is not helpful. So we'll have to use the given equation and try to, get a proper form in which we'll be able to find out what a, b and c are. So let's go ahead and try that. Now again you may ask me that who is going to do all this analysis in the exam? Well, when I explain, it takes some amount of time, but if you are good at calculations, if you are good at numbers there, you can quickly think of 2-3 different random solutions and establish if you can at least get the answer or not, right? If this is the right way to go ahead or not. If you don't feel comfortable, then just try to do some other solution or just skip and move to the next one, right? So let's look at the given equation and see how does that help us in finding out the correct answer. So we have a squared plus b squared plus c squared equals to 2 times of a minus 2 times b minus 2 times c minus 3, right? So what do we do? Let's take everything on the left hand side. A squared plus b squared plus c squared minus 2a plus 2b plus 2c and plus 3, right? Plus 3 equals to 0, right? Now if you really look at the given terms, we have a squared minus 2a, b squared plus 2b, c squared plus 2c, and we have one constant 3. Now maybe if we have a squared minus 2a plus 1, it can be taken as a minus 1 the whole square. Likewise, we already have b squared plus 2b, but if you have one constant 1, we can say b squared plus 2b plus 1, these three terms together can be expressed as b plus 1 the whole square, right? And we have c squared plus 2c. So if you have 1, we can say c squared plus 2c plus 1 equals to c plus 1 whole square. So all we need to do now here is split the number 3 into 3 parts. What is that? 1 plus 1 plus 1. So that we can use, each one here in 3 different cases. So what do we get? A squared minus 2a, I'm taking plus 1, plus b squared plus 2b plus 1, right? And finally c squared plus 2c plus 1 equals to 0. Now let's write in the simpler form. A square minus 2a plus 1 can be taken as a minus 1 whole squared, plus this can be taken as b plus 1 whole squared, right? Plus the last part here can be expressed as c plus 1 the whole squared equals to 0. Now sum of 3 terms is equal to 0. The easiest solution will be equate each one of them to 0, right? Let's assume every term is 0. 0 plus 0 plus 0 will be equal to 0. So if this is 0, what happens? A minus 1 equals to 0 implies a is equal to 1. B plus 1 equals to 0, which implies b equals to minus 1. And c plus 1 equals to 0 implies c equals to minus 1. Again, you need not write all these 3 steps in the exam and waste your time, right? You can understand that a should be 1 and b and c have to be minus 1 there. Now that we have got the values, substitute in the required equation, right? 2a minus 3b plus 4c. So this will be equal to 2 into 1 minus 3 into minus 1 plus 4 into minus 1. So this is 2 plus 3, right? Minus 3 into minus 1 is plus 3. So 2 plus 3, 5. 5 minus 4 equals to 1. So we can say that the answer for the given question will be equal to 1, which is option B. So for such typical questions, I think we'll either have to find out the solution of A, B and C by doing some random substitution, or expand or reduce the given equation in such a form to see if we can get the values of A, B and C in some other way, so that we can substitute those 3 values in the given equation, that is 2a minus 3b plus 4c in this case, to find out the final answer.